All right, sample problem 2.7 says that it wants us to predict the monatomic ion formed by each of the following elements. And the first one we have listed is iodine, and it says it's C equals 53. So I'm going to bring up the periodic table real quickly, and we're going to find iodine on the periodic table. All right, here it is. I've got Z equals 53. Now, to figure out what kind of ion or what kind of charge these main group elements are going to form, we first have to know about noble gases. And this column right here, 8A, group 8A, are the noble gases. And these guys all have outer filled electron shells, which we'll talk more about as we get later on into the semester. Now, all of these main group elements want to achieve noble gas status. So they want to make it to this part of the periodic table. So what you have to do is you first of all have to look at what we're interested in. So we're interested in iodine. Then I have to determine which noble gas is it closest to, right? And I look at the one before it, and I look at the one after it, okay? So this is number 53. So it's going to be closer to xenon, number 54, than it is krypton, number 36. So then the next step, now that I've identified it wants to get here to xenon, I've got to figure out what's exactly going on. So it's going from 53 to 54, which means it's gaining an electron. It has to increase its number, has to gain an electron. Anytime something gains an electron, it's going to have a negative charge associated with it. And the number of that charge is just going to be however many times it had to move. So this one had to move one time, so its charge is going to be -1. So let's write that down. On A, we're going to have iodine with a -1 charge, okay? And that's exactly how you write it. You represent it with a symbol and the charge, the monatomic charge. All right, let's check out the next one. The next one is calcium, Z equals 20. So let's bring back up our periodic table. And let's see what's going to happen here. All right, I find calcium. There it is, number 20. And I have to see which is the closest noble gas. So the one directly after calcium is going to be number 36, krypton. All right, and then if I go backwards, the one before calcium is number 18, argon. Now, number 20 is closer to the number 18 than it is to the number 36. So number 18, argon, is where calcium is going to want to get to. What does it have to do to get there? Well, its number's 20. It has to lose 2, right? It has to go back to 18. Now, if you lose electrons, the charge associated with that is going to be positive, okay? And so then I have to figure out how many times did I move. I moved 1, 2, or 20 minus 18 was 2. So the charge on the calcium ion is going to be +2. So let's back out a minute and write that down. So B, I'm going to have calcium with a 2+ charge, a +2 charge. Now, that brings us to the types of these ions I want to mention real quickly. Things with a negative charge are called anions. Things with positive charges are called cations. Okay, so A is an example of an anion. B is an example of a cation. All right, let's see. What's next? We have aluminum, Z equals 13. So let's bring our periodic table back up and find number 13. All right, there it is, number 13. So what's the noble gas after number 13? It's going to be argon, which is number 18. The one before aluminum, I got to go back this way, is going to be neon, number 10. Number 13 is closer to number 10 than it is number 18, right? It's only 3 away from 10, where it's 5 away from 18. So aluminum is going to want to make it to neon. What does it have to do to get there? It has to lose 1, 2, 3 electrons. Since it's losing electrons, going to be a positive charge. It's going to have a 3+ charge. So let's back this out and write that down. Going to have aluminum, Al, aluminum with a 3+ charge, a +3.